Hi, this is Rubaat Khan, and this is the second lecture of the series. In the previous lecture, we were working on a binary tree. We were given a binary tree, and we were given a task with it, and that is to paint. So we started from the root node pointed by n, and then we moved left. Did the same task as we did on A, and that is color it red, and moved left again. Did the same thing, color it red. By the way, this will be D, and then move left. So at some point, we will reach a dead end, which is basically a node with no child. So when we reached a dead end, what we did was we went up and then moved right and did exactly what we did before. This one task, painting and then moving left or right, was being performed within itself. If we consider this piece of lines as a code or as a function, you'll see that the same function paint was being called within itself. So this is the function paint, and inside paint, the same function is being called, and this is working just like a loop. This problem-solving technique is called recursion. We can say, or we say recursion to be reoccurring of a function within the function. Now let's convert this into a proper function. So say I'm writing a Python code over here, so I'll start with def, and I'm naming the function paint, and n is the node initially, which is the root node. Now, before we get into the description of the function, let's try to guess, or let's try to figure out a couple of questions. The first question is, how would we know if n, or the pointer, has reached the dead end? Or in other words, how would we know if n has reached a node with no children? The second question is, how to move up when n reaches a node with no children. So let's answer this one first. Binary trees are just like linked lists, or to be precise, doubly linked lists. Each node has two pointers, left and right, just like a double linked list. So each node has two pointers, left and right. Therefore, the left and the right pointers of D, so if I look at the tree, the left and the right pointers of D will have none. Okay. And this is how we will identify if we have reached a dead end or not. So we can write if n is none, then we move up. Now, how to move up? Well, for now, let's say this moving up takes place automatically. We do not have to write any code for this. Why? We will explain, or we will get to know in the next slide. So let's say simply we move up, okay? So this takes place automatically, no code. So this is I've written in a comment. Else means if n is not none, which means n is a valid node, then what we do is we move to the left child, that is n dot left, and recursively apply the paint function. Again, when we are done with the left child, we move to the right, which is n dot right, and then we recursively call the paint function. Okay, these two operations take place if the node is valid. And if we move, and if we reach a none, and that is like this, if we reach over here or here, we the program will automatically go up. And why this thing we'll get to know in the next slide. Okay, see you in the next slide then.